Hello. En direct, okay. Ooh, okay, let's go back to coding. So the first thing is that I have to fix the pause. Okay, where were we? Yeah, Zig build. Oh no, cd, what was it? Zig Ray? Zig build. Okay, so the problem was that the pause button escape didn't work. I have to fix this now. How to do that? G.inputs.escape. Okay, not this one. Here. Oh no. Okay. So this line we have to move it somewhere else. Should happen here, I guess. I will have to move this somewhere else later, but for now this should work now, I guess. And let's try compiling. Done. Let's run this. Okay, pause is happening. It's happening again. Happening. I press, and then we have pause, but then the game.pause doesn't get false or something. Okay, we have jump, we pause it. It's true. Ah, okay, I see what's happening. So when we pause it, we don't have the update in inputs anymore. So update inputs should be outside of the. So where is the process here? This call should be in run function in the loop. Now every time update inputs happens, true. Yeah, it's okay now. It works. Now, there are two things that I have to fix. The first one is that when the collision happens here, the velocity gets 0, but the position shouldn't be it shouldn't be near position 1. So when we are hitting a block, both vertically or horizontally, we need to fix the position of the player to be just in front of the block. That's the problem. And to do that, I think in our collision, I have to change the collision code and somehow fix it to something else. I don't know what. Because, okay, no. So the collision should return us when we are asking check collision function. It should return us the coordinates of the player where player can stand. Like the last position before its collision, I guess. How do we do that though? Let's go check this function. Now, before doing that, I'm gonna remove some of the comments that I made here. This might be needed in the bucket. Okay, let's go back to the check collision function. Or is player move valid? Is player move valid? here. Here I am finding first, so the player is a capsule. I find the left, right side coordinate, left side coordinate, top and bottom coordinates. And I check only the new position. I don't check the previous position. I don't check the what is in between them. So that's the first thing that needs to change. So we have to check if the player in moving between from one position to another position passes through some tiles or some some blocks, some block tiles. And if that happens, then we should force the player to stop right there in the middle of the transformation. That's the first thing that needs to change. The second thing, so let me write this before. Previous position, and that's also vector 2i. So basically we are moving from previous position to new position, and then I need to check if in these in these places if there are blocks and if these blocks have collision with the player. So that's the first thing that needs to be done. The second thing is that the return shouldn't be just Boolean. It should be the exact position of, so if it's, so I can return a vec2d I, a vec2i. So if it's null, then it's how do we say? Then there is no collision. If it's not null, then that's the place of the player to stop the transformation. That should help us with a lot of stuff. Like I think with dashing also, this should help us. Like yeah, this is the best way to handle this, I guess. Layer, no, it's okay. Here I have to add g dot layer dot pose. This is the previous position, and then here also exactly. We come back here now. First I have to see from previous position to the new position. So the movement, ooh, that's it's gonna involve a few blocks. We can calculate first left. Left is equal to if propose of this 0 is less than new pose of 0. It's yeah, exactly this one. Right is also the same. I need up and down, top and bottom. Yes. Okay, now this left one. Okay, left becomes, yeah, this is not new position 0. This should be left. This is right. The next one is top, and last one is bottom. Okay, so that means that we sweep from the previous position to the next position all the way. And we consider all the blocks, and we see if there is a collision between any of the blocks in this way with the player. If there is, then player has to stop right before this collision happens. Okay, how do we continue this? So the first thing first, this thing can be null. And then if we move down, here I can return null. Okay, now here I shouldn't return true. I should return some position for the player to stay there. Okay, it's a little bit weird, but I guess this should work. But then if it detects the collision in some blocks sooner than the other block, like for example in horizontal way sooner than the vertical way, wouldn't it be a problem? Could be a problem, but I guess I have to see in practice how this thing goes. So first I have to see what's the position of the tile and player with respect to each other. So if the tile is top left of the player, then that means that the player is going towards top left. And yeah, and it has to stop, like the position of the player should be like we should calculate it with respect to this I and j that we have here, the new position of the player. Ooh, this is a little bit interesting. Is there no easier way? I mean, I'm starting to think that maybe there is an easier way to do this, but I guess I have to do this. Like I have to go step by step, like smallest steps, exactly like just the size of the tiles, and see if there is a collision between any of the tiles and the player. And then Okay, I see. So there would be no major problem even if we get a horizontal collision sooner than a vertical collision in this way. We are calling this function like 2 or 3 times in when we are doing the whole processing of the player position and stuff movement. That means that we are going to have full control of the results in any situation in general. So it doesn't matter if it knows some collision sooner than the other one. We just needed to return some position for the player to stand over. Okay, so first thing first, if um, oh, actually, I don't have to. I mean, I will have to change this function later. I guess I'm just going to use it like this. I don't have to use this because preposition is just a g.player.position. But since I don't have to pass the variable preposition. But it's okay. Let's go for now. Let's see if this is working. Then I will be I will change this so that it is efficient. The first thing that we need is to know if player is over or under the block. To know that, we just say player that position, or let's just use the same. I'm gonna change this again later, so why not? Position 1. Is it over? Is it okay? This is under. So if this is more than, so for tile, the position of the tile is I and j. This should be j times tile size, game.tile size. Um, and then what? If it's over it, we can just say return vec2 I. Okay. G dot player dot position 0. J times game dot tile size -1. Okay, there should be if, yeah, tile is blocked, by the way. Okay. So right now, if player hits the tile from above, then we set the position for. Okay, here I have to consider player radius also. So I have to say -2 times g dot player dot r. Okay, and this -1 is so that it's just 1 pixel above the tile. That should work. Only vertical cases. For horizontal cases, we should check for g dot player. Okay, but then if the actually, I should change this so that we check exactly from which side player is having collision with the tile, though. It's not exact. Like we have to know if it's like diagonal or if it's horizontal or is it only vertical. How do we do this? Because, so for example, the vertical one now works. Probably, yeah, it's okay. I mean, this thing is now working for the vertical cases. And then if we have only horizontal, no, yeah, there should be another condition for if we are hitting from the bottom. Yeah, I have to do this with every case. Like I have to check all the 8 angles that one player can have with either that or is there another possibility? Ooh, this is interesting. Okay, so I think that there should be some algorithm um, that's already known that helps me to do this, to find the exact location of the player before collision. Yeah, I guess yeah, I think this is more complicated the way that I see this right now is that I have to have the direction of movement completely. Like I have to consider the player movement as a vector. Why? Because, so for example, there is a sort of, okay, maybe I can just draw this on paint somewhere. Maybe it's easier. Okay, so our player is something like this. And then there is a platform that is rectangle. Player is moving like this. And there is a collision. Then the program should return us this location as the rightmost place to for the player to have. Now this is the case one. Another case would be that if player is on top of the tile coming down, then we need this location, which is the most top part of the thing, as the location for the bottom part of the player for the player to stand over that location. So we need this X and Y. And then if player is moving like this, we need this location. And number 4, if the player is moving like this from bottom, we now need this location. But that's not the only thing that needs to happen, because there is more stuff. Okay. Okay, let me draw more. So number 5, if there is diagonal movement, the player goes like this. Then the location should be this distance is, so if this is the center of the player, if we consider the center, the distance here should be exactly player radius, basically. So just to remember, This is R. This is R. Oh, sorry. This is 2R. And then this is R. This is R. That means that if this is the center, this is the half size of this player capsule is R. So we need to stay in R distance between. There should be the distance between these two should be R plus 1, basically. Delta X. And delta Y should be also R plus 1. So seeing this picture here, it should only, so there is delta X should be R plus 1. The distance should be R plus 1, but the value should be added here, whereas here delta X is again R plus 1, but the value should be decreasing, like the value of X for player should be less than, because for the platform, the X and Y is this corner, the top left corner. For the player is the center of the player. Okay. So what I'm gonna do, I have to check what's the position of player with respect to. So I'm gonna write a function. Player, okay, get player tile side. I guess, I don't know. I mean, it's a good name for the function to remember. Get player side, get tile side, get player tile side. It's okay. And then so player is in game, but for the tile we have to pass tile coordinates, tile coords, which is a vec2i, and then it returns us a side. Okay, now what is this side? Side is pub const side is equal to enum. There is, okay, there is left, there is right, top, bottom, top left, top right, bottom left, bottom right. That's it. Okay. Now here, okay, this function will return where player is with respect to a tile. So if player is top left of the tile, it should return TL. Okay. To do that, we just do a bunch of left is g.player dot position 0 less than tile core 0 times game.tile size. Const right should be is g.player.position 0 is more than tile core 0. Yeah, exactly. Let's see. Okay, so if this is bigger than tile core 0 times tile size plus tile size, yes, that's true. Then player is on the right side of the tile. Top means I can do this function with two, so I don't need to have this one. I can have player character, so it's like I can say character, for example. I can use it later for enemies and stuff also, this function for collision of the enemies. So I'm going to change it to character core, and this is a vec2i. And this is, so character doesn't need to have, oh, okay, there is something here. So to check if it's on the left, right, okay, that's correct. We can also check for overlap. Because the enemy has some size now. But then this is not even useful in some cases because the player is not a rectangle. It's, why do I need this again? Oh yeah, I wanted to know what's the direction, like directional movement of player with respect to tile coordinates. But I can't get this Hmm. Is there another way to get this done? It's easier. Like, can I do vector calculations? So I can have a vector that says, so player movement is clearly a vector. There is a the older position, and the vector starts from older position and goes to the new position. And then we need to detect a collision between this vector and any of the tiles segment. So, okay, there is an easier way. I mean, I don't know if it's easier, but there is a more, maybe better way to do this. So let's do a new, don't save. So this is x0, y0. And this location is x1, y1 for the player. Now we have some kind of a rectangle here for platform. We want to see if there is a collision. Instead of doing the collision like, I mean, I was trying to keep it simple, but then if you keep it simple, you just don't get some of the information, some of the important information. To get the important information, instead of just considering this to be a block, what I need to do is to have, if this vector has collision with any of the sections of this that enclose this block. If I do that, I can use this for any shape after this. Like I can have a line, I can have, and then if there is intersection, that means that there is a collision happening at some point, and I can even have this collision point. If I keep the game specifically only to polygons, like if I only work with the polygons, this is really good because this could be really useful and help me with later adjustments that I need to make. So I just need to consider segment, which is like each edge or each side of the block or polygon, or even a line, basically. Collision with a vector. And my vector is the player, and segment is like part of the platform. And then if there is a collision, I need to have there. I need to have, what is it called? The collision point. I need to get a collision point. And this collision point is important because I know that if there is a collision, player has to stop somewhere. this returns us where the player has to stop. And this is also good for enemies. I can use this for everything in the game, basically. This is really good. So now I just need to find a simple algorithm that helps me detect collision between a segment and a vector. So there is a simplification here. I mean, for now, I can only consider that my segments are horizontal or vertical. And then consider the player as a vector, player movement as a vector. And this should simplify the collision detection. So how do we do it? So dx is just x1 minus x0. dy is y1 minus y0. And this gives us our vector v is just dx and dy. That's our vector for the movement of the player. Now for the collision point, for the segments, I have a platform. Okay, and then depending on where this first position is with respect to any of these things, how do I do this? So I can have a case where this is a little bit more complicated. So for example, if the vector goes like this, I have to identify the first collision point. Because this is also a collision, but I don't want this. This is a bad one. The collision that is closer to the to do that. So for platforms, like for example for rectangles, we know that okay, so this directional, actually this thing helps us now, this code that I have. Because now this detects if collision, like here I can care for which sides should I care for the collision. Is it top left? Is it top right? Is it bottom left? Is it bottom right? That means that from this information, I actually know which side player could collide first. the tile. So this is interesting. Now let's do a vector segment collision. Okay, I actually don't know how to do that, so I'm gonna ask some AI help. How to do vector and segment collision. Okay, array segment collision logic. A segment AB can be represented parametrically as with direction D, can be represented parametrically as this. True. Then we have array or vector with at C with direction D, can be represented parametrically as PRU C plus UD, where U is positive. Okay, for an intersection point P, we set these two equal to each other. S, B, B minus A, the segment vector, array vector. This is a system of two linear equations, one for x component and one for y components with two unknowns. We can solve this using Cramer's rule or by substituting one variable. We do cross product, and then the formulas for t and u are cross this divided by cross that. And implementation steps. Okay. And then you do that. The problem is, can we detect if the collision point is just exactly, oh, we have to transform it to integer at the end. It's okay. Let's go back. So, oh, okay, sorry, I just forgot to show you what I'm trying to see here. Very maybe this one. Does it run? It's okay for now, I guess. So what I'm trying to do is now I'm asking AI to help me with the ray segment collision logic. So I have AB as the point. B minus A is my vector. So this is A is the first position of the player, B is the second position, like the last position of the player. C, okay, array vector starting at C with direction T. This is the array CD. You can have this, we have this kind of equation. We call S as B minus A and R equal to D for some reason. Why do you change D to R? I don't know. But anyway, R is just D and S is B minus A. And then we solve this system. To do that, there is a cross section and division to be done. And finally, we can get what we want. Like we get the t variable and we get the u variable, and therefore we get the collision. So here is a problem that I have. So the question that I have is that when do we know if they are parallel? Also, how do we know ooh, let's do this for now. Okay. When to know if they collide the segments and not continuation of each other. If they are parallel, if the denominator k, which is the cross section, is 0, then that's parallel. And then r is array direction vector d. Okay, since the cross product to d is 0, if only vectors are collinear, parallel. 0 using a small epsilon floating point comparison, the lines are parallel. If they are parallel, they will never intersect unless they are also collinear, lie on the same line. Check for collinear overlapping segments is an extra step, often involving checking C minus A is parallel to S and R, and then checking for overlap using dot products or simple 1D interval overlap. Okay, The intersection point line lies on the segment AB if the parameter T satisfies this. If it's less than that, is extending behind A. That's past point B is between that, the actual hit on the physical segment, ray constraint. The ray starting point at C with direction R is defined parametrically by intersection on the line extending backwards from the ray position, so we don't care about that. If ray positive, if U is positive, then the point is valid. Hit along the ray's travel direction. Okay, U also needs to be between 0 and 1, right? No, the parameter U, which takes the distance along the ray. No, if I'm considering the ray to have some certain length, so that's important that U is between 0 and 1. This is when the ray is infinite, that we don't care about U as being less than 1. But he doesn't understand that, so it's okay. So what I'm gonna do is to have that's the first thing. The second thing that I need to check. Okay, I can do this. This is actually not complicated. It should be like 10 lines of code, maybe, hopefully, like 10 to 20 lines of code. But this is not the only thing that I should do. Also, the ray position, if I bring back my paint. And then, okay, this should be set. We go back to paint. So here, let's renew this. No, so here, this is the first position of the player. X0, Y0, basically A. And then player moves like this, and this is our vector. Which is equal to x1 and y1. Now, this is not the collision point. This is not the place to the last point of this player. I should extend this line. I should extend this vector until it considers the full right side of the player. So the collision point is valid. That's why I have to first calculate this point. And to do that, so I have to first find what's the slope of this thing. So to find the slope, consider this point to be B. And this point to be, sorry, this point to be D. So I have to first calculate B minus A, right? No, sorry. So how did we calculate the slope? It was it's just bx, by minus ay over bx minus ax. And then if this is 0, this is an infinite loop, infinite thing, so they're basically aligned. If this is 0, that means it's a horizontal. Horizontal means that by minus ay is equal. Vertical means that bx minus ax is 0. Since I'm only considering tiles here, tile collision. But I mean, I can do a more complicated version, like because I'm going to use it later in the game. Then I have to extend this, or I can just do it arctangent arctangent 2. I can use this function arctangent 2. I give them delta y and delta x, and it will give me some angle. I will use this angle to calculate this thing, this extra thing that I have to add. So I just need this part, right? So I get the theta, this is the theta. Here is that, this thing is this. Oh, this is a little bit difficult to draw it on the computer. I'm gonna try first on the paper here. Oh, it's more complicated than I thought. It's not just this thing, because so this thing is itself a square. So what I'm doing is trying to calculate the collision with the square. And of course, this part is a half circle. There is a half circle on top. This is a, yeah, I have to I don't know. It's getting more complicated. It's like I'm trying to solve one thing using the problem that I have. I don't know. I'm going around myself a little bit. So how do I fix this? Further clarification. Okay, so I'm trying to ask the AI for this some help. How can I proceed this thing? Because I really don't know how to go on. Player movement vector has a certain length, so I explained this. Segment collision. Not array segment collision. Okay, your collision is between two finite line segments. Yes, that's correct. And collision logic is the same thing. Exactly the same thing. Okay. Is that yeah. U and T must be both between 0 and 1. That I know. Okay. Strategy for tile-based collision. Player move segment might enter. Yes, okay. Tiles that intersect this movement significantly reduces the number of segments you need to check. Edge extraction, segment generation. Okay. Ooh. Continuous collision detection. Eh, So for player, which is capsule, I have a bounding shape, which is a rectangle. And then I have to check every step of the way which tiles it is blocking, it is considering. And then okay, I don't know if I'm gonna use this, but I'm gonna keep it for now. Will it? It has to go through the tiles. How do we do it? Player has a size, it's not just one ray. That would be hmm, capsule is moving. You're no longer doing simple line segment collision, but volume to volume collision. Okay, the general approach to use separating axis theorem from Minkowski sum principle, which are often simplified into processes called swept collision. I actually don't know what is this thing. Oh, just to show you what I'm trying to do. I'm asking AI how to proceed with the collision between player and the tile that I have, tile system that I have. It's not just a vector collision because I have to consider the whole shape of the player and then consider if it collides with any of the tiles. Player's shape, okay, the size of the object you are testing against is generally much easier than trying to solve for capsule segment intersection directly. This technique is called Minkowski sum, or Minkowski difference in geometry, but the idea is simple. A capsule to swept circle is essentially a line segment with a circle defined by the capsule's radius r on both ends. Two endpoints and checking them against the environment. You can simplify the player collision shape by assuring the player to a line segment. Capsule central segment as a collision path. Ooh, that's interesting. Okay. I'll expand the wall, the tile segment outwards by the capsule radius r. So for example, in horizontal, I have to extend it in with r and okay, not that one. Okay, so it just says that, for example, this is tile and this is player. Consider player as a line in the center and then extend. So this is r and this thing is 2r. So I will have to extend this thing by 2r and extend this side by r. And then I would have to see if this line has collision with this shape. Right? No, sorry, if this point is inside this thing, this rectangle, which is really easy, it's just a one condition thing. I will just check if this point is inside this rectangle. That means that there is a collision between this thing and the tile. Um, what is it? Binary tree? No. Hi, how are you doing? No, this is not binary tree. So I have a tiling system, and I have a problem with the collision. Like, my player is um, a capsule shape, and the shape is like this. I mean, this is, well, how do we draw capsule? This is not capsule. I have to do this, and then, do you have half circles here? No, you don't. Hmm. Okay. Like something like this. I mean, it's not exactly circle, so but you get the idea anyway. Uh, what's happening? Oh no, okay, I see. You have to draw first and then pull it. So this is a half circle. I mean, I didn't completely correct, but anyway, you get the idea. And this thing is R, this is R, this is R, but this thing is 2R, which means that the total height is 4R and the total width is 2R. And then, yeah, I have a tile with some tile size. I will call the tile size TS. So it's a square. And I want to see, like I want to check the collision of this player. So, and where does this come from exactly? It's comes from like yesterday. I don't know if you remember, but there was a pause in player movement, and it was because the collision was not correct. So the player would see the block from further away and just stop before it really gets close to it. Instead, I need to have not just if player collides with the block, but also the point that it collides, like the first point that they collide. I need to have that point so that I can put the player there, like so that I stop the player one point before that, like something like this. And then, yeah, that's why I was trying to. So first, I was trying to consider this as a vector, but then the vector doesn't work like this. But then the vector doesn't work. I have to consider a shape. Oh, sorry for that. Okay. And yeah, that's it. It's a little bit complicated. That's what I'm trying to know. And now, so we consider if this point is there, then there is a collision between this tile and this point here in the center of the player. I mean, I'm asking AI for help, but then it's not actually really, like, I don't completely understand how to do this, honestly. Maybe I should use a library for this. I mean, I can try to use Box2D. Let's see. Okay, I have to put this out of your view for just a few seconds so that we can see what I'm searching. Let's try Box2D. Box2D for Ziglang. Make cross-compile Box2D easier. Foreign language. 10 months ago, it's a master thing. Does it work with? I mean, I can just import the C library, by the way, in Zig, so it's really easy. But that's not the problem. The problem is how to use it. Are there examples here? So you're familiar with basic physics concepts such as mass, force, torque, impulse. If not, please first consult Google search and Wikipedia. Tutorial Game Development Conference. You can get these tutorials. Publication section of the G or G. Six-word solver, then is now advanced time, resolve contact entering question. Function solver that operates in order in where the n is the number of constraints. Continuous collision, the solver advances the body. I'm using discrete time steps without iteration. This can lead to tunneling. Creating a world. Every Box2D program begins with the creation of a world object. The world is a physics hub, manages memory, objects, and simulation. The world is represented by an opaque handler called v2worldID. We define some world, and then the world definition is temporary object. I think I have to start a new project just to test Box2D. Like, I should try to separate from Raylib the thing that I have here, separate from this code. I should try a new test project, like a small one. Or maybe I can do it in this one as well. Just try to define a few objects in this box 2D thing and then try to use it. So there is like gravity. They're actually floating points, okay. And then you can create some objects. What is this object? B2. Okay, you create the world, okay, I guess. You define gravity. This is the information of the, it's like a world information. You put the information that's needed for this world, like gravity, what is gravity, and then you create the world. And you put it in world ID as the ID of the world. The world creation copies all the data it needs out of the world definition so that the world definition is no longer needed. So now we have our physics world. Let's start adding some stuff to it. Creating a ground box. So the problem I have with the floating point action is that we're dealing with pixels. And I don't understand why they're using floating point, because there is the precision, like too much precision is not really helpful. Sometimes it leads to weird situations. Like you expect that because it's an integer, you expect that some line collide with the corner of a rectangle, but then if you use a floating point, it might add some accuracy that is not needed, and then we might not see the exact collision. I don't know. Maybe there is a way to handle this situation, this kinds of situations. There is a ground body definition. So I mean, Raylib has some collision stuff, but then the collision stuff in Raylib is not also interesting. It has also problems that I don't know. Creating. Okay, for step 1, create the ground body. Ground body. Position, you put a position for the ground. 0. And then you create it. You do polygon, ground box. Make a box in 5010. Do you give the size to this box? It gives it default shape. It's so weird. There is no, like in box 2D, there is no size for the box. How do we? I cannot imagine like how this is doing things. I don't know. It's a little bit. I'm lost. Here I understand that there's this gravity thing, so. And the gravity, we have to put it positive. Here it puts it negative. But the problem is that when you add box to the, you have to change everything in the code so that it corresponds to Box2D as a library. But I already have like the gravity system, velocity and stuff. Yeah, I would have to change all of that just by adding Box2D, I guess. Keep a reference to the shape ID. It copies the data into internal data structure. Creating dynamic body. Like, I really don't understand what's happening here, because this is like, so every 2D shape has some kind of a size, no? Like, how do you do things? Like ground body, okay, you have a ground, you're defining a ground here. But then here you're doing a ground box. What does it mean, ground box? I created a ground polygon. I used this box helper function to form a ground polygon into a box shape. With the box entered into the origin of the parent body. Ah, okay. So basically this is a size. It's like 100 times 20. Yeah, okay. So horizontal size is 100 and the vertical size is 20. You get the half width and half height. And this is, you give the size, make box. And then you have to assign this to the ground shape, ground body. Create polygon shape, ground ID, and then shape definition and the ground box. And then you can, yeah, okay, you're creating like this. Okay, I see. Box3D does not keep a reference to the shape data, okay. Definition, there's a type, position, and then body. Okay, there is a lot of work to do just to learn this. That's a lot of work, and I am not really. Yeah, okay. I don't know. Okay, I'm gonna try to learn how to do this, and I will come back, I guess, in the afternoon. I will think about what I'm gonna do next, and then I'm gonna stop the stream right now. Maybe there are easier way to do it than using Box2D and stuff. I'm pretty sure there should be. Yeah, hopefully I will find a way. Thank you all for watching and being here. See you again this afternoon, like in a few hours, like 2 or 3 hours, I'm gonna go eat, rest a little bit, try to search for a little bit stuff that I can do, and then yeah, hope to see you again.